All right, hey everybody. Wanted to say this this morning, and it's really interesting. The human brain processes the passage of time across three distinct stages. It's from May 13th this year. Um, a recent study mapping the brain reveals that our perception of time does not happen all at once, but rather unfolds across a series of distinct physical processing stages. As visual information travels from the back of the brain to the front, different groups of neurons handle specific parts of the timing process, ultimately creating our subjective experience of how long an event lasts. These findings were published in the journal PLOS Biology. Uh, it says, despite knowing where these timing regions are located, researchers have struggled to understand exactly how they work together. And these three people here, Valeria, Valeria Centanino, Centanino and her colleagues Gianfranco Fortunato and Domenica Bueti, I'm sorry if I don't pronounce this stuff right, at the International School for the Advanced Studies in Italy, conducted an imaging study. And they wanted to track how the properties of time tracking neurons change as signals move through the brain. And here's their profile there on cognitive neuroscience. Uh, that's what her main focus is there. Uh, and there's his all his works, Gianfranco, uh, same, and her as well. And there's the Wikipedia for it, the history of it. I'll leave links for all this and the top universities. Trieste, uh, to the city where it's located. Really interesting history there. Uh, you want to check it out. Uh, uh, narrow strip of Italian territory lying between the Adriatic Sea and Slovenia. So, and it was once belonged to the Habsburg monarchy from 1382 till 1918 there. Anyway, really interesting history, there. Um, anyway, let's get back to here. Okay. Uh, they recruited 13 healthy volunteers to perform a visual categorization task. The first they were trained to memorize a specific reference duration of a half a second, which they'd use as a mental benchmark. They watched a series of blurry, flickering circles appear on the screen. Each circle stayed on the screen different amounts of time, random, uh, ranging from 2/10 of a second and 8/10 of a second. After each disappeared, the participants pressed the button to indicate whether the shape was visible for longer or shorter. Uh, while they performed the task, the researchers recorded the brain activity using an ultra high field functional magnetic resonance imaging scanner. Boy, that's a long one. Uh, it was the field strength of 7 Teslas, much stronger than standard hospital scanners. To detected changes in the blood flow, uh, the oxygen-rich blood rushing to that region of the brain. And it says they found that the way neurons tune into time change depending on their location in the brain. They identified three distinct processing stages that form a hierarchy of time perception. First stage occurs in the occipital visual areas located at the back of the head where the brain first processes sight. The neurons acted like simple timers that gathered sensory information from the eyes. Uh, in these areas, the brain cells showed a strong preference for the longest durations, and it increased steadily the longer the shape stayed on the screen, encoding the physical length of visual event. Second stage takes place in the parietal and premotor regions, which sit near the top and middle of the brain. In these areas, the researchers observed a complete topographic map of time. Neurons in these middle regions were tuned to the entire range of presented durations. Some groups of cells respond only to brief flashes, while others responded only to medium or long. The specialized cells were neatly organized into clusters based on their preferred durations. Suggests that the parietal and premotor regions are responsible for reading out the specific duration of the visual event, allowing the brain to track exactly how much time has passed. The final stage happens in the frontal regions of the brain, including the anterior insula and the rostral supplementary motor area. These areas are heavily involved in complex thought, decision making, and self awareness. In these frontal areas, the neurons did not represent the full range of time. Instead, they showed a strong preference for the middle of the time range, which was close to the half-second reference duration the participants had memorized. The central preference represented the boundary that participants used to decide whether a duration was short or long. By tracking the exact time at which participants switched their answers from shorter to longer, the researchers calculated each person's unique suggestive boundaries. Each one's, of course, we know each one's different. Everybody perceives different. It's shit. Our results showed that time perception is not a unitary process, but the outcome of multiple processing stages distributed across the cerebral cortex. Each stage contributes differently, from encoding physical duration to constructing the subjective experience of time. Like say, it's fascinating. There, this is fascinating. Want to read the whole article there, but like say that the passing of time, like you're sitting on your phone, sitting on the computer, and you don't realize how much time's passing because we on the cookies yesterday. So it's Caliber. I was talking a little bit about that, about time. But anyway, uh, the flicker rate affects that. You don't think you're sitting here that long, but you've been sitting here hours and hours. Been guilty of doing that. We all have. Anywho, just uh, wanted to put this out there. Uh, really interesting. Uh, so anyway, let's see how do I get out of here? Okay, okay. Anyway, take care, y'all. Have a great day, and I'll see you next time.